Good morning. Welcome to this lecture in the second week of this ongoing online course, which is on Engineering and Architectural Graphics Part 2. And in this course, we are talking about isometric projections so far. So, what we have done so far is understood the fundamentals, the basic principles, the basic procedure of arriving at the isometric projection of any object. It could be a point, a line, a plane, or a 3D object, a solid. So, depending upon how the object is placed, how it is being cut, we also looked at frustums of the cones. So, how it is being cut, we have understood how to draw the isometric projections. One thing which we also learnt is, before we draw the isometric projection, we have to have the orthographic projection of the same object in place. So, isometric projection is an addition to orthographic projection, which enhances our capability to view it in the 3D, to perceive it in 3D, and it makes the drawing much more clear, easily readable. But to arrive at the dimensions, to actually construct it, we would still need the orthographic projections and the drawings. So, today in this lecture, we are going to look at the isometric projection of sections of solids. Some sections of solids, for example, the frustums of cones, we have already seen in the previous lecture. So, we looked at frustums of cones and also frustums of pyramids. We also looked at some of the sections of these pyramids and cones. Today, we are going to look at the isometric projections of sections of solids. So, the first problem we are going to look at here is that of a cube which is being cut by a vertical plane. It is a simple problem. Let us see how do we arrive at these points. Okay. So, I am going to draw a reference line here so that we understand what is going on. I am sure by the time I finish drawing, you would have already finished drawing at your end when I am trying to solve this. But when I am solving this, through this we are reasserting the fundamentals and the basic procedure of arriving at an isometric projection from a given orthographic projection, which is here. Okay. So, what we are doing right here is we are first enclosing this shape. I am only taking this shape here. Okay. So, let us see this. So, what we have is we have this point 1, 2, 3, 4 and 5. Well, I am just taking it not random, but I am assuming it. These distances, you will, when you draw, you will take the exact distances. So, this is what you are going to get in the base. Okay. We could have started from drawing the square. So, in case we were drawing the square first, okay, so this appears a little distorted, but we would actually be seeing a line, these lines being parallel to each other, and then from this it is cut. Okay. So, we see this remaining shape. Now, we know the height. Okay. So, we know the height of each of these points and it is exactly the same, it is not changing. So, we have this height, say 3 units, and we just draw these 3 units and keep joining them. So, another 3 units, 3 units here, because the heights remain the same, and you can see that all these lines are parallel, which is what we are also getting here. All these lines are parallel. So, this one again and this. And now, you can just darken it. It was a very simple exercise. All we did was take the same heights, just arrive at the base shape which we arrived at after the section was cut through the cube. This is what you are going to see in isometric. A simple solid, all we are seeing here is So, this is the cut surface, this is the section where it is going to come, and this is what you will actually see. It is actually quite simple, and if you look at this now, if you look at this orthographic projection, this drawing, yes, this is required to arrive at this, but if I look at this drawing, I immediately get an idea, oh, this is a cube that is being cut. Now, here I have actually not drawn the remaining portion. Suppose we were to draw this remaining portion as well, like this, and we make even these surfaces evident somehow. You would also see that this is how it is getting cut. I can extend this plane and also show that this is the section plane which is cutting. So we know that, okay, this is the plane which is cutting this solid, which was actually this, and then we cut it. This is the section surface that we arrive at, and this is the solid that it looks like. So, this is the isometric projection of a cube which is cut by a vertical plane. Okay. Now, let us look at this one. This is a cylinder, a circular cylinder, right cylinder, which is getting cut by a plane, an inclined plane. And now, we will try to draw exactly the same thing again. So, we have already drawn the isometric projection of a cylinder earlier. We will do it again, the only thing being that this is cut by an inclined plane. So, this is our xy. So, what I am starting to do here is again draw the circle first of the base, which apparently remains intact even after getting cut. So, we still have the base intact. So, we will arrive at this base. Right. So, this is the base. Now, we know that this is an inclined plane. This is actually an ellipse. This is the true shape of this section here, but where is this ellipse going to come is what we have to determine. So, we will make this enclosing rectangle. It appears to me more of a square. Now, where is this going to come? So, this is actually a plane. So, where is this going to come? And in the plan we will still see this. Okay. So, we will have it in two places. So, one here and one there. Let us make this. So, where do we take the height from? Let us take, this is the first height which we are taking. So, if I raise it say here, this is where the first one is going to come. We make a square here. So, it is a rhombus. So, this is the same reference square, but here this is where we have already made it here, and now I am going to make it here. So, this is the remaining height. We take it again. Okay. So, I am just reducing this height probably because we do not have much space. I should have started. So, this is where the upper one comes. This one comes here. Okay. Now, from the front view, we already know that this plane, this cylinder is getting cut by a plane which is slanting like this, right. So, this is the plane where the points of this are going to lie. Now, we have to arrive at these points. So, the simple ones are these 4 points which are here. So, this one here, this one in the middle of this one in the middle of this, and this one in the middle of these. These 4 points we know. We can arrive at, now we know the horizontal distances and also the vertical distances of both of these. So, we can actually arrive at these points. I can just be drawing these horizontal lines, right. So, we can actually draw these horizontal lines on this plane like this, and we can also have their respective heights coming, right. So, we can actually have these respective heights coming and also in this y direction. So, we can actually have it coming in the y direction and then dropping their heights. So, x, y and z. Similarly, x, y and z like that. So, we can actually arrive at these points. So, I am not exactly getting at these points, but this is how you will be arriving at these 12 points in which we divided the circle. Okay. So, this is the isometric projection of this ellipse, which is what we are going to get on this plane. Every time we are doing these drawings, we are making these drawings, all we are doing is we are identifying the planes which are cutting the original solid, or where this inclined plane is being contained. Now, we already have this final drawing, so we will just join. Okay. This is what it is, and now if I darken it, you will be able to see the final picture. So, we will be seeing this one. Okay. So, this is the top ellipse which we have. This is the vertical surface, the edge which will be seen, and then we have the bottom part which is left and some dotted part at the back. This is the isometric view of a cylinder which is getting cut by this plane. Now, I can draw, as I said, or maybe rather we will take a different color here. So, this is the plane. I can just extend it. So, you can see this clearly here, right. So, this is the plane which is cutting the cylinder, right. And if I want to hatch it, you will see that this is the sectional surface, and actually the true shape of it is an ellipse, which is this, and which is what approximately you can make a sense out of this, that yes, this is an inclined surface and probably an ellipse. So, you can perceive it better. The whole point of drawing isometric projections is to improve the perception. We can manufacture it, we can draw it, but then if we see clearly that what this object looks like, we can actually make a better perception about this. Let us look at another one. So, this is actually a prism which is kept on one of its rectangular faces. Okay. This is what we are seeing here. Now, it is inclined. So, it is inclined and it is also being cut by a plane, a section plane which is parallel to the horizontal plane. So, we have several planes here. This is one inclined plane, this is another inclined plane, this is one flat plane, and this is another flat plane. So, let us see how we can start by drawing it, by drawing the reference rectangles. So, this is the reference rectangle for the base, right. So, I will start with drawing the base first. So, this is the rectangle that I am talking about. Okay. Now, I identify these points. So, this is say E, this is F, this is B, and this is another one. Okay. So, what I will do here is, now ideally since these two are parallel, we should be getting parallel lines here. Ideally we would be getting that. So, there is slight deformity here, but you would be getting the parallel lines here. So, this is the base rectangle which is drawn here. Okay. Now, we have to arrive at this rectangle. Okay. We can either arrive at this rectangle, or we could also be drawing this triangle here. We can be doing that. Okay. So, either ways you can do that. So, maybe we will start with this one. So, we can take only the cut part of it. So, I make a rectangle here, I make another one here, but for this one, so we are only looking at this part, right. So, this is this shape. So, if I make another rectangle here, this, okay, in the plan, and for this we have another rectangle in the plan, and this is where the elevation of it is going to come. Let us make this rectangle here. So, what we have is we have a rectangle like this here, okay, and for this one we have a rectangle here. This is the one which is going here, and this is the one which is coming here. Now, we have a rectangle in front. So, say like this, okay. So, we will just take it again, extend it. Now, on this one we have these points coming, say 1 and 2, okay. I am sorry. So, we actually have it like this. So, which is parallel to this, and then we will have these points on this, which are actually getting joined to the base like here, and the similar thing we will do here. We again have an inclined plane here. We identify these 2 points, and the bottom ones are intact, and we can just join that. On the top we are joining this and this and this. If I darken it, I hope you are following this. This becomes a little messy sometimes to understand, so you have to follow the lines that I draw. This is what you are going to see as a section of this triangular pyramid. This is the dotted line, this is the dotted line that we are talking about, okay, and this is another one. So, this is the prism which is getting cut, and this is the section surface which is apparently a rectangle, and we can see this. So, this is how we can also see that how it is inclined. This is xy, we can see the inclination to xy. We can also see that it is getting cut by a plane like this. So, we can actually mark the plane which is cutting this entire prism. If you wish, you can also extend these, and you will be arriving at the original shape of the prism here, which after getting cut looks like this. So, this is another condition, but I am repeating these steps and I am trying to solve several problems through this. You would be able to understand how to arrive at these isometric projections for these different solids. The only thing being that for every different type of solid, for example, here we are looking at these sections, it is not necessary to draw the original full object first sometimes, but other times it might be necessary to draw the complete object to arrive at where the section is coming, or where, in case of the combination of solids, how it is going to come. Okay. This is another one where it is actually a hollow cylinder. So, it is a cylinder which has certain thickness, it is not a solid cylinder, it is hollow in between, this is what you can see, and it is inclined, and it is also getting cut by a plane which is parallel. Now, because this cylinder was inclined, even a parallel plane parallel to the horizontal plane cut it, resulting in an elliptical shape, which is what we are trying to draw here. So, let us start drawing this one here. We have a reference line. Okay. So, now what we are going to do is we are first going to arrive at this base circle. So, this base circle remains intact. This is what we see in the elevation. Okay. And so, this base circle is actually now inclined. So, we will see its original inclination. So, we will not be seeing it. So, we should actually be drawing it in dotted, but this is how we are going to see the bottom. Okay. So, what we will do? We will first make this. So, there are actually two rectangles which are enclosing these, right. So, we are drawing these two rectangles here, one and say 2 here. this one. And now this is not a circle anymore. What we are seeing here is actually not a circle. We have to take the height of it, and then for the inner one we can, this is where the inner one is, we can take another rectangle, right, but it has a different height. So, let us first figure out the outer one. This is what the outer one is going to be, and this one is actually contained in this plane, which is this plane. Now, we will again see how those 12 points are coming, what are their distances. We always have at least the 4 points for our reference. We can arrive at the rest of the 12. This is the outer one, and if we do the same thing, so this is where it starts. So, we will actually have another cuboid within this, which will be defining where the inner one, the inner ellipse comes. So, we will also have approximately something coming like this. Okay. The only thing being that this is not the final one which is going to be seen. So, we have anyways arrived at these two ellipses in the bottom. Okay. Now, we have to arrive at the top one. So, let us first look at the outermost one. So, this is the outermost ellipse. Now, this outermost ellipse is actually parallel. So, we know that this is actually parallel and this is the height. Okay. We just need to know the reference from where it will be taken up. So, we will first draw it in the plan. So, if you look at this, probably this is the rectangle that we are talking about. Okay. This is how it is, and then we just raise the height, say this one. So, we raise the height and draw this rectangle at this height. So, this is where we have now drawn, and now we can actually draw the outer ellipse and also the inner ellipse. The inner ellipse is also going to come at the same level. So, you can arrive at the points which will be the defining points for the ellipse, and then draw them. And similarly, you can arrive at a smaller rectangle. Within this rectangle, bring it up and draw the other ellipse, again by taking the reference points. So, 4 points or 12 or whichever way. We could also be doing like a grid. So, in isometric, the grid sometimes comes handy because you do not have to measure it, because these grids are going to be parallel to the axis, and hence these are the isometric lines and easier to measure. So, this is what the top of the cylinder is going to be, and this is what the bottom of the cylinder is going to be, and now we would just join. Okay. So, this is what we are going to see, and inside there is a hollow surface. Now, if I color it, what you would see, we would just be seeing this. It might be a little distorted. Now, these two lines are definitely going to be parallel to each other, because they are parallel in this object. They will appear, they have to ultimately come parallel to each other. Ellipse, and inside you will see that there is, this is the hollow. You can actually have this a dotted line which is connecting the hollows inside like this. So, this is what the isometric projection of a cylinder which is getting cut by a plane, an inclined cylinder, hollow cylinder, which was getting cut by a plane which was parallel to the horizontal plane will appear to be. So, I hope with this the steps are again clearer. We will take more 3D objects, another set of 3D objects, and arrive at their isometric projections in the upcoming lectures. So, that is all in the lecture today. Thank you very much for joining me. Bye-bye.